Observation 1. Of the point of a sharp small needle. From Micrographia, or some physiological descriptions of minute bodies made by magnifying glasses. By Robert Hooke, published in 1665. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. As in geometry, the most natural way of beginning is from a mathematical point. So is the same method in observations and natural history the most genuine, simple, and instructive. We must first endeavor to make letters, and draw single strokes true, before we venture to write whole sentences, or to draw large pictures. And in physical enquiries we must endeavor to follow nature in the more plain and easy way she treads in the most simple and uncompounded bodies, to trace her steps and be acquainted with her manner of walking there, before we venture ourselves into the multitude of meanders she has in bodies of a more complicated nature, lest, being unable to distinguish and judge of our way, we quickly lose both nature our guide and ourselves too, and are left to wander in the labyrinth of groundless opinions, wanting both judgment, that light, and experience, that clue which should direct our proceedings. We will begin these our inquiries, therefore, with the observations of bodies of the most simple nature first, and so gradually proceed to those of a more compounded one. In prosecution of which method we shall begin with a physical point, of which kind the point of a needle is commonly reckoned for one, and is indeed for the most part made so sharp that the naked eye cannot distinguish any parts of it. It very easily pierces, and makes its way through all kinds of bodies softer than itself, but if viewed with a very good microscope, we may find that the top of a needle, though as to the sense very sharp, appears a broad, blunt, and very irregular end, not resembling a cone as is imagined, but only a piece of a tapering body with a great part of the top removed or deficient. The points of pins are yet more blunt, and the points of the most curious mathematical instruments do very seldom arrive at so great a sharpness. How much therefore can be built upon demonstrations made only by the productions of the ruler and compasses, he will be better able to consider that shall view those points and lines with a microscope. Now, though this point be commonly accounted the sharpest, whence when we would express the sharpness of a point the most superlatively, we say as sharp as a needle, yet the microscope can afford us hundreds of instances of points many thousand times sharper, such as those of the hairs and bristles and claws of multitudes of insects, the thorns or crooks or hairs of leaves and other small vegetables, nay, the ends of the sterae or small parallelepeds of amianthus and alumen plumosum, of many of which, though the points are so sharp as not to be visible, though viewed with a microscope which magnifies the object in bulk above 1,000,000 of times, yet I doubt not but were we able practically to make microscopes according to the theory of them, we might find hills and dales and pores, and a sufficient breadth or expansion to give all those parts elbow room, even in the blunt top of the very point of any of these so very sharp bodies. For certainly the quantity or extension of any body may be divisible in infinitum, though perhaps not the matter. But to proceed. The image we have here exhibited in the first figure was the top of a small and very sharp needle, whose point nevertheless appeared through the microscope above 1/4 of an inch broad, not round nor flat, but irregular and uneven, so that it seemed to have been big enough to have afforded 100 armed mites room enough to be ranged by each other without endangering the breaking one another's necks by being thrust off on either side, the surface of which, though appearing to the naked eye very smooth, could not nevertheless hide a multitude of holes and scratches and ruggednesses from being discovered by the microscope to invest it, several of which inequalities, as A, B, and C, seemed holes made by some small specks of rust, and D, some adventitious body that stuck very close to it, were causal. All the rest that roughened the surface were only so many marks of the rudeness and bungling of art. So inaccurate is it in all its productions, even in those which seem most neat, that if examined with an organ more acute than that by which they were made, the more we see of their shape, the less appearance will there be of their beauty. Whereas in the works of nature the deepest discoveries show us the greatest excellencies. An evident argument that he that was the author of all these things was no other than omnipotent, being able to include as great a variety of parts and contrivances in the yet smallest discernible point, as in those vaster bodies, which comparatively are called also points, such as the earth, sun, or planets. Nor need it seem strange that the earth itself may be, by analogy, called a physical point, for as its body, though now so near us as to fill our eyes and fancies with a sense of the vastness of it, may, by a little distance and some convenient diminishing glasses, be made vanish into a scarce visible speck or point, as I have often tried on the moon, and, when not too bright, on the sun itself, so could a mechanical contrivance successfully answer our theory, we might see the least spot as big as the earth itself, and discover, as Descartes also conjectures, as great a variety of bodies in the moon or planets as in the earth. End of Observation 1 of the point of a sharp small needle, from Micrographia, or some physiological descriptions of minute bodies made by magnifying glasses, by Robert Hooke, published in 1665. Read by Sue Anderson.